Let us look at proposition number 13 of book 9 of Euclid's Elements. The proposition says, if as many numbers as we please, beginning from a unit, are in continued proportion, and the number after the unit is prime, then the greatest is not measured by any number except those which have a place among the proportional numbers. So what the proposition is saying is, given a continued proportion starting from 1, and the first number after the unit is a prime number, then the last number, that is D, is not measured by any other number except the numbers that are there in the continued proportion. So let's see how we can prove this. The proof is a little bit convoluted, so please focus. We are given unit A, B, C, D in continued proportion. A is a prime number. Now we are going to use proof by contradiction. So if possible, let E, a number not equal to ABC, measure D. So E is not going to be a prime number. Since E measures D, and based on one of our previous propositions, we saw that if a prime number measures D, then it also measures A. That is what it would mean. But here, A is a prime number. So no number can measure a prime number. So that is why we are saying E is not a prime number, which means it is a composite. And if it is a composite number, then it is measured by some prime number. E is not measured by any other prime except A. How can we make that claim? Because if E is measured by another, then that other measures D. So the other number would also measure A, which is a prime number, which is not possible. So we say A measures E. Since E measures D, let it be according to F, which means basically what? D is equal to E times F. Okay, let this F be not equal to ABC, because if F equal to ABC and measures D according to E, then remember, we know A, B or C measures D according to A, B or C. One of the numbers measures D according to some other number in this continued proportion. This is one of the propositions we have already proved. Which means what? Which means F equal to A, B or C, and E will be another number in this continued proportion, but which is against our supposition here that E is not equal to AB. So that is why we are saying F is not equal to A, B or C. F is not prime. Again, we are going to follow the same procedure here again. So F is not prime since it measures D, which would imply that it also measures A. But A is a prime number. So no number can measure a prime number. So which means F is composite. So is measured by some prime number. And we are saying F is not measured by any other prime except A. Yes. So again, same reasoning like this. If F is measured by another, then that other measures D. So the other number would measure A, which is a prime, which is not possible. So we say A measures F. D is equal to E times F. Where did this come? D is equal to E times F. And in a continued proportion starting from 1, we know A times C is equal to D. So D equal to A times C. And here if you notice, left hand sides are D's. So we can equate the products. So A times C is equal to E times F. And this we can write it in proportionality form. A is to E is equal to F is to C. We already know that A measures E. A measures E. That means F also measures C. Since F measures C, let F measure C according to G. So again, we follow this. Similarly, G is not equal to A or B, and A measures G. C is equal to what? A times B. C is equal to A times B. And C is equal to F times G. From where did this come? F measures C according to G. So that means C is equal to F times G. And here again C is C. So we can equate the products. A times B is equal to F times G. And in proportionality form, we can write it as A is to F as G is to B. But we already know that A measures F. A measures F. How do we know that? Because here, if you notice, we have said F is not measured by any other prime except A. That means F is measured by A, which basically means A measures F. So since we know A measures F, it means that G also measures B. Okay? Let G measure B according to H. And here H is not equal to A. B is equal to G times H. And in a continued proportion, we know B is equal to A times A. So we can equate the products. G times H equal to A times A. In proportionality form, we can write it as H is to A as A is to G. And we know A measures G, which means what? Because of this proportionality, that H measures A. But remember, A is a prime number, and we have said H is not equal to A. If H was equal to A would have measured A. But since H is not equal to A, therefore a contradiction is reached. So, which means there is no other number except those which are there in this continued proportion that can measure D. That is the last number in the continued proportion. So that was proposition number 13 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can benefit from it, please do share. That's it for now. Bye.